Okay, so this is the 2007 question 10A higher level. So we've a passage about Cockcroft and Walton, and then we were asked to draw a label diagram to show how Cockcroft and Walton accelerated their protons. Okay, you can see this. Okay, all right, I'm breaking my number one rule. I'm drawing in pen. Anyway, we have a hydrogen source up here. This is in vacuum. Hydrogen source. And then we have these plates. Now, what did they go from? I think it was like 6,000, wasn't it? I don't know, 600,000. Hang on, let me look this up. There we go. 4J, that was not 400 kilovolts, 200 kilovolts, and 0 kilovolts. Okay, and then down here they had their lithium target at 45 degrees. What was the question? How they accelerated their protons? Great, that's probably enough. Just draw a little plus in there. Okay, what is the velocity of a proton when it is accelerated from rest through a potential difference of 700 kilovolts? Okay, I'm going to just go across here because it's easier. That was part one, this is part two here now. What is it? Oh no, this is still part one, isn't it? Oops. Okay. The velocity of a proton when it's accelerated from rest through a potential of. So what are we doing? So the voltage is 700 kilovolts. Okay. But I need to change that by get that into joules in a second. So what I want to know is the total energy on it. So I'm looking for kinetic energy. Wait, the velocity. Yeah, I need to know kinetic energy. So kinetic energy is a half mv squared. All right. But I don't know. Oh yeah, sorry. I want to know the velocity, but I want to know the kinetic energy. So how much energy does it get? The energy that it gets when it crosses a voltage. That's just QV, right? So energy is charged by voltage, big V. So that's going to be, they're going to be equal to each other. Okay, so I've got a half V squared is equal to charge on the proton times the voltage it's being accelerated through. So that means the velocity is going to be 2 times all of that, and then square root it, I think. That makes sense. 2 times the charge times the, yeah, that should be okay. So it's the same as a charge on a electron. That catches some people out sometimes. And this is 700 by 10 to the 3. And I'm dividing by the mass of a proton. Looking it up there. 1.6 by 10 to the negative 27 kgs. Get my calculator out. Right, square root of 2 times 1.6 by 10 to the negative, 10 to the negative 19 times 700,000, and dividing that by 1.6 by 10 to the negative 27 for the kilograms. Oy, 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 oy. Yeah, I hate when I do 1, 2, 3, 4, 5, 6, 7. Okay, so our velocity is 1.18 by 10 to the 7 meters per second. So pretty fast. Okay. Write a nuclear equation to represent the disintegration of the lithium nucleus when bombarded with a proton. Okay, so I got my lithium nucleus, and I'm adding a hydrogen hydrogen what? A hydrogen nucleus, it's a proton. What's lithium? 3 and 7. So we are going to get 2 heliums out, two lots of 4-2, yeah. That's it. Okay, calculate the energy released in this disintegration. Okay, so this is mc squared stuff. Alright, are you still following me? So energy is equal to mass times the speed of light squared. So what I need to know is the energy before, energy afterwards. And we're doing it by mc squared, okay? Okay, what I could do is, instead of doing equals mc squared on both sides, just get the mass of these and then the mass of this in total, find the difference in mass, and then use this formula, okay? So the change in mass, I'll come back to that in a second, is the mass of the lithium plus the mass of the proton minus the twice the mass of a helium thingy. Okay, so what do I have? Mass of lithium is 1.1646 by 10 to the negative 26 plus the mass of the proton. I should probably be more accurate this time. Let's go with the number they gave us. That is a minus twice the mass of a helium nucleus, 6.6443 by 10 to the negative 27. Okay. So 1.1646 by 10 to the negative 26 plus 1.6726 by 10 to the negative 27 plus my bracket, take away 2 times 6.6443 by 10 to the negative 27 plus my bracket. Okay, so my change in mass is 3 by 10 to the negative 29. So with me, there you are. And then from E equals M, what was the question? I hate when this happens. Calculate the energy released. Yeah, so we're just going straight E equals mc squared. So now it is 3 by 10 to the negative 29. And we want to use their speed of light that they give us, 2.9979 by 10 to the 8. Mr. Scanlon, don't be so silly. Okay, multiply that by 2.9979 by 10 to the 8. Oh, damn it. Squared. And I get an answer of 2.696 by 10 to the negative 12 joules. It's energy.